It's not all bad. But yeah, I think this test will be a pleasant surprise for many people. But before we do it, I do want to just cover two topics. We won't be doing an extra quiz today because that would just be crazy. That would be asking you guys way too many questions. So yeah, we'll just jump right into these two extra topics I want to cover quick. It's really small things that I don't think you guys will have trouble getting. If anyone is struggling though, then please just, you know, post in the chat if you want an extra bit of explanation or something, okay? But it's just two ideas that I think most of you, you'll get, I think. So the first one is just a fourth command for queues and stacks. So if you remember, we covered queues and stacks a while back, I think like 2 lectures ago, actually. And
yeah, this is a new laptop.
Rohan, your mic is on.
Oh, that's our teacher.
Okay, yeah, that's fine. Cool. 2 more people joined. Good stuff. All right, so yeah, I just want to cover these two topics quickly. So we covered stacks and queues, right? So stacks, we had 3 commands, right? We had push, pop, and peek. So hopefully you guys remember what all of those do, right? Push will add to the stack, pop will remove from the stack, and remember, so it adds to the top and removes from the top because that's how stacks work. And peek will just show you whatever's on the stack. And in a way you can see like peek will show you the next thing that would be popped, right? So it shows you the next item to come off of the stack. And we had queues, right? Where we had NQ, which would, or in queue, which would add things to a queue, DQ, which would remove things to the queue. And remember, it'll add to the front of the queue, right? Because that's how queues work. And peek, which would just show you what's at the front of the queue, the next thing that would come out of your queue. Okay, so I've got a little example of a queue here, and but you can picture we can use the command peek on a stack as well, right? So this next command I want to show you is the same as that basically. You can use it on stacks or queues, whichever one you want. Actually, this one can be used on linked lists as well. And it's a fairly simple command. It just either returns true or false, okay? So what I've done here so far is just peeked, okay? So I created a queue, I added the number 1 to the queue, the number 3 to the queue, the number 5 to the queue, the number 7 to the queue. 1 was the first thing I added, so it's at the front of the queue currently, right? So hopefully you guys, you understand that when I say peek, it prints out 1, right? Because 1 is at the front of the queue. The other command I want to show you, just so that you know it exists and what it does, it's not difficult to get, I don't think, and we can maybe run through a few examples together. And it also just makes sense from what the name of the command is. I also added it to the slides. So I just posted the slides on the WhatsApp group before I posted the reminder. So it's in the slides now as well to remind you that it exists. The command is dot contains. Dot contains. Okay, dot contains. So as you can probably imagine by the name of the command, contains, it will just tell you whether or not the queue or the stack or the list that you're using this on contains a certain item, right? So I've got 1, 3, 5, 7. I can give contains any item and it will tell me true if that item is in the queue or the stack. It also works in stacks or the list. If it is in the structure, and if it's not in the structure, it will return false. Okay, that's all this command does. So it just, if you need to see what's inside a structure, you would use contains. Okay, like if a particular item exists within a structure. Okay, so for example, you guys can answer the question. If I say my queue dot contains cat, what do I expect this to print out when I click run? Anyone? 0, yeah, I guess false, right? It would say false. yeah, I mean, 0 is similar to false in a way, so forgiven. Actually, we could check that out. That might be fun to do. And yeah, you guys are correct. It prints out false. So yeah, that's correct. So, and I mean, you can picture like if I ask for 6, what do you guys think? What do I expect this time? Yeah, still false, right? 6 is not in the queue, right? 6 is not in the queue. So so notice this is going over the whole queue, right? So 7 is at the back of the queue. But if I ask my queue dot contain 7, what do I expect now? True. Yeah, true. Because 7 is in the queue. Okay, so I apologize for not covering this when we initially covered data structures. It was seeming like I don't know. It's now in the slides, so whatever. But yeah, it's a pretty easy thing to grasp. So cool. If there's any questions about it, please do ask. Because yeah, it is obviously there would be niche cases, and if you're wondering anything, then yeah, go ahead, far away. But yeah, hopefully this one's okay. The next topic that I just want to tell you guys about might seem a little more scary, but you'll adjust quite easily, especially to the type of way that the MTA asks it. So I'm going to leave this for now. So that's contains. It will just tell you whether or not a data structure contains a specific item. You give it the item that you want it to look for, and it will just tell you false if it's not there and true if it is. Okay, that's literally all it does. The next thing I want to talk about has to do more with, well, I'll just show you. It might appear a little bit scary. Okay, so we're moving back to arrays, so flashbacks. So this is an array, right? I've just created an array of numbers. It has 12 elements, 1 through 12, right? And you can imagine that they're indexed by 0, 1, 2, 3, 4, up to 11, right? So I can access numbers in position 0, and that would give me 1, right? And when I run this, you see it gives me 1. If I access numbers in position 5, it will give me 6, right? Because we just start counting at 0. So hopefully we're pretty comfortable with that, okay? But there is like a special way to work with arrays that we didn't really discuss, because the way that they ask it in the MTA, they ask like a very brief question, but they ask the questions in a very specific way. So I think maybe it's better to just cover it this way. Okay, so as like a topic on its own. So here we've got an array. I can make an array what we call a 2D array, so 2-dimensional. We call this kind of array 1-dimensional. The reason we call it 1-dimensional is because it only has one index, right? Like you can say 0 for position 0, and like put it this way, each item in the array is indexed by one number, right? One number. So hopefully you get that. There is a way that we can make it indexed by 2 numbers. So that's the complicated, maybe a more complicated, more abstract way of thinking about it. But in a very real way, you can think about this as just creating a table. Okay. If you understand a table, then you'll understand this. So I'll just do it, and then you can see we can see what you guys think. Okay. So when I say table, I literally mean a collection of rows and columns. Okay. So what I'm going to do, we've got our numbers here, right? So currently it's still a normal array. All I've done is pushed enter to make it look different, right? But currently it's doing the exact same thing, right? Nothing has changed. C# doesn't even see the enters. I'm just making it easier for us to read. Okay. So you can see I've got a number of different rows here, right? We've got our 12 items, and we've got them in a number of different rows. I can tell C# that I literally want this to be a table or a 2-dimensional array. Okay. So how I would do that is there's just 2 little changes I need to make. I need to surround each of the things that I want as my rows by another set of curly brackets. So you see, I've made this almost like it's its own array. Okay, so this is an array that is like actually holding an array now. And I could do the same with these. And I could do the same with these. Might look freaky, but it is literally just a table, right? So this is row 0, row 1, row 2. Okay. Hopefully we're still, you guys are still with me. The other little change I need to make, and it's just what C# needs, everything needs a type, right? So just having square brackets like this is an array. If you put a comma there, then it's a 2D array. Okay. So what does this change? What does this mean? Oh, do you still, sorry, it's blocking by this. Do you still need the comma after the, yeah. So that's splitting. So you could think, there's multiple ways to think about it, Alex. You could think about this as an array of arrays, right? So inside the array defined by these outer curly brackets, the ones that Rex Tester are highlighting now, there are 3 arrays, okay? So you could think of it like literally an array of arrays, or you can think about it as a table, okay? But basically, just like when I had them all on one line, like if I wanted my array to hold 1, 2, 3, I have to put a comma between each item. It's the same here. Each array is like an item. So I need the commas there. Okay. So like each row is an item in the array, if you think about it. So, but it'll make more sense when you see how this question is asked. Okay. Yeah, exactly. So there's 3 arrays inside the array called numbers in a way. Okay. That's the more technical way of thinking about it, but there is an even easier way of just thinking about it like a table. Anyway, but let's see how this works. Okay. So basically what this comma means is that there's now 2 indexes. Each number is indexed by, each item rather is indexed by 2 numbers, right? Like what row it is in and what column it is in. Okay. So how would we think about that? So if I wanted to access the number 6, for example, I would say, all right, it is in the second row, which is, so this is row 0, because remember we start counting at 0. That doesn't change. We always start counting at 0. So it is, so the array it is in would be 1. Okay, so like 1, comma, and it's, so we start counting at 0. I'm trying to access 6. So it's row 1, 0, 1. So it'll be 1, 1. Okay, 1, 1. And you guys will see that that will give me, array initializers in a field. Wrong number of indices. What did I do wrong here? Sorry about that, guys. Right, I removed the comma as well. Okay, whoops, my mistake. You can see it gives me 6. Okay, you do need the comma there or it'll give you that horrible error. You can see I accidentally backspaced the comma and it gives me all of that. But yeah, if the comma is there, it reads it as a 2D array. So sorry, that was a silly mistake by me. But you see it gives me 6 because 6 is row 1, column 1. But we start counting at 0, obviously. So this would be 0. So 1 here, the first one is 0. That's a O. 0, 0. And that gives me 1. Okay. 0, 1. So that would be row 0, column, the second column, so column 1. That will give me 2. Okay. So you can read it like a table where you index with the row that you're looking for and the column that you're looking for. Okay. How do we feel about this, guys? I think it is very similar to a normal array, right? Where I hope we're all okay with it. But let's try a few just to get the idea of it. Can anyone tell me what do I expect to come out if I asked for 2, 3? What do I expect to come out when I ask for 2, 3? Oh. Wow. Okay, that was quick, and a lot of you guys answered. So it seems like you guys are okay. I'll go through it though. So how would we do this? So I'm looking for row 2, right? So I'll go 0, 1, 2. Okay. And I'm looking for the third item. So 0 would be 9, 1 would be 10, 11 would be 2, and 12 will be 3. And so, yeah, all of you guys were correct. It's 12. Okay. So, yeah, you're basically just, it's the same as a normal array, except it's now twice, right? What would the application of a 2D array be? Well, if you wanted a table in memory, you would use that. Actually, though, Kiara, the most frequent use for this would be images. Like if you have a gray image, like a black and white image, it would literally just be a single 2D array with each of the pixels' brightness being a number. So that's quite an interesting use for what 2D arrays are for. And like maybe you can think about how that would work, right? And yeah, but there are lots of other applications. But yeah, if you were ever representing a table, you would represent it in a 2D array. But yeah, images are probably the most frequent use because yeah, it's you could see how you could build up an image like this. Okay, cool. But yeah, basically all you guys will be asked in MTA about like 2D arrays is yeah, number one, they I guess they could ask you like an application question like that, like you need to store a table or an image inside the they probably wouldn't ask this because it would be very difficult to ask as multiple choice. What they will ask though is how do you index a 2D array? So if you're asked for 2, 3, what number would it give back? Okay, so this is the main thing. So I think firstly, just remember that it's indexed row, column. Okay, the first number is the row you're looking for. The second one is the column you're looking for. And feel free to draw it out as a table if that's the way you're thinking about it. But like I said, it is actually just an array, right? So if you prefer thinking about it that way, it seems like Alex prefers thinking about it that way. It is literally just a normal array. All of these things can be on one line, right? They could it means the same thing. This is the same. You can see it's just that the first item is an array, the second item is an array, and the third item is an array. Whether you're thinking about it like a table or an array, it doesn't really matter. Okay, you can do it how you like, as long as you know how to go from row, column to the actual item inside the 2D array. Okay. Cool. Oh, and also, so might seem clear, but just in case, if anyone has the question, if all the rows need to have the same number of columns, okay, put it that way. So like you can't have a row with 3. This wouldn't be allowed. You wouldn't really be asked this, but just out of interest, so maybe you can understand because it's sort of like a homogeneous type, right? If you, because it's fun getting technical sometimes. So for those of you who are interested, you know, just like our array always, they're homogeneous, so everything has to be of the same type. So this array has a type. Its type is sort of like an array of integers with length 4, right? Because you can see that every single item in this array is an array of length 4 of integers. So it needs that fixed size. Okay, so all the rows need to have the same number of columns is basically what I'm saying. Okay, and it does work with strings as well. So I'll just show you guys. So if I say string, comma there, I'll say names equals, I'll just make a small array, comma. Okay, I'll just put the last few people who posted in the chat. So Kiara. Okay, and this will work as well. So if I access names in position 0, 0, Kiara, 0, 1, Erika, 1, 1 would give Alex, and 1, 0 would give Vivette. Okay, oh, I pushed enter. Would give Vivette. So it works with any type. Okay, so it's what's showing that it's a 2D array is the little comma inside the square brackets. Okay, I think probably the easier way to think about it for this purpose is like a table with just indexed by rows and then columns. Okay, so yeah, I just wanted to cover those two things because yeah, I went through the test myself and I think it would be unfair to send you in without covering this. So yeah, we can. Cool. So it was just contains. Remember that contains works with queues, stacks, everything, and it'll just show you if the item is in the data set, okay, is in the data structure, I should say. Okay. So the next thing we would go on to do is the test. We've only been going for like 20 minutes, but maybe I'll give you guys like short time just to sort of stretch your legs and then we'll get started on it. Okay. So let's say we'll start the test at 15:25. I'll post it in the chat and on the WhatsApp group. And yeah, I'll obviously stop sharing my screen because I'll probably go through the test as well while you guys are doing it. So it'd be a little bit pointless if I was sharing. Okay. Cool. But yeah, so we'll get started with the test at around 15:25. It shouldn't take too long. It's like the previous ones, probably a little bit faster actually. So yeah, probably about 45 minutes-ish. Shouldn't have any need to rush. Okay, link to the test posted in the chat and on the WhatsApp group. Ooh, I did actually tell Vesh that he could join at 3:30 because he was getting home from school late. Here's the link to the chapter 3. Who did I miss out? Okay, yeah, so you guys can start when you're ready. Let me know when you finish, but I'll remind you to when we get like halfway through the time. What time do we expect to finish? Probably 10 past 4 you should aim for, maybe even 5 past 4. If I can ask you guys to avoid that last 5 minutes. Ooh, and there is one more sort of suggestion I wanted to make, but let me open the test quick. Yeah, last thing I would say is page bottom. So for question 16, the bottom of page 80. Okay, if you're struggling on question 16, then look at the bottom of page 80. That's the last thing I'll say. So wait, let me. I didn't set the test, and this question wouldn't come up in the current MTA. So, but yeah, strange. I found a nice YouTube channel that explains all of the sorting algorithms, including bubble sort, in like Hungarian traditional dancing. So I'll share those on the group, and then hopefully question 16 would make more sense to everyone. But that hasn't happened yet, so. Yeah, it is interesting. I don't know how they came up with the idea. But yeah, I'll post the link to the bubble sort in Hungarian traditional dancing on the WhatsApp group after the lecture. So for those of you watching on YouTube, the class just finished writing the test, and we're like on a break now. Okay, I am going to start a little bit earlier, just because what I'm going to show you first is not strictly relevant, but I made a thing while you guys were writing instead of going over the test again. Well, we are going to go over the test now. I'm saying instead of me writing the test while you were, I just did this instead. So this was Kiara's question about what 2D arrays are used for. So there's this thing. I just wrote some Python code. It's not a lot. It's like literally nothing basically. But you can see here when I run this, this is a 2D array, right? So it's an array of integers. The first row is just zeros. The second row is 0, 255, 255, 255, 0. Third row is 0, 255, so the same as the previous one. The, fourth row is the same, and then the last row is all zeros. So what's quite cool, I don't know if you guys have ever seen this like 8-bit art before, but this is sort of how you would make it. So zeros will be shown as black, 255 will be shown as white, and all the numbers in between can be like various shades of gray. So if you look at, if I make a display, so this exact 2D array here, if you display it as an image, you get this. So like a black square, that's all the zeros. And then the white square in the middle is all the 255s. So this is what you can use like a 2D array for. And you can see it's labeled. So like 0, 0 is this square here. And like that would be 1, 1, 2, 2, 3, 3, 4, 4. So you can see like how it's indexed as well. So yeah, that's one of the things you can use 2D arrays for, but there's obviously lots of other things. And so obviously this image is only what, like 1 to 5 times 5, 25 pixels. So it's very low resolution, but you can imagine if you have like 1,920 pixels or whatever, you can make very complicated black and white images. But yeah, anyway, so with that out of the way, not strictly a part of the course, but I thought a little bit interesting maybe. Let's go over this test. So let's start where we would start, right? Question 1. This one's not too bad, right? Like, so arrange the various activities of an application life cycle in the order which they are likely to occur. Requirements, design, coding, testing, and release. So it sounds about right. We sort of explained this. So it's, let me put it this way. If you don't get this one, then maybe watch the first lecture again. Although I guess it is easy to forget, so that's fair enough. But it makes sense, the flow, right? So requirements analysis is where we find out what it needs to do. Design, we actually design the app that we're going to use to solve those requirements. Coding, we actually build the app. We then have to test what we built, and then we release it. And they say are likely to occur because it is a cycle, obviously. So you can hypothetically jump straight to design. But yeah, it's most likely to go in this order, which sort of makes sense. Let's not spend too much time on that one. You are planning to develop a new software system for your organization. You need to review the plans, models, and architecture for how the software will be implemented. Which of the following activities should you review the output? So you're planning, you need to review the plans, models, and architecture. You see, the fact that they say review is a little bit suspicious, but the answer is design. And you can just think about it because, like, if we're talking about plans, model, and architecture, we're talking about the design phase. I think, yeah, using the word review is a bit weird. You are planning to develop a new software system for your organization. You need to review the system's technical blueprint. Which of the following participants is responsible for providing the technical blueprint? So this one we did discuss, right? We call these technical blueprints architectures. So who would make an architecture? Weird grammar, but who would do it? It would be an architect, right? A software architect, but an architect nonetheless. So you are planning to develop a new software system for your organization. Someone needs to be responsible for developing manuals and help files. I actually asked you this question in the quiz last week, because when I was going through this the first time, I was thinking, we didn't discuss job descriptions that much, although it was technically that reading, like the required reading. So I did actually ask you this. It was differently worded, but it was a very similar question in last week's quiz. And the answer is a technical writer. So, I mean, obviously you do write manuals, right? And you do write help files. And the only person out here who would write is the writer, yeah? So that's the other way to remember. Like a user interface designer is not, you could hypothetically say they should make user manuals, but would they make help files? Content developer, we know what they do. They develop content. So like if we were creating YouTube and we're about to release it to the world, but it has no videos on it, like how would people start using this site? User interface designer. Yeah, I mean, the designer has enough to focus on. They don't have to write the manual as well, right? You are planning to develop a new software system for your organization. You need to verify that the implementation of the system matches with the requirements of the system. Which of the following activities would accomplish this requirement? So in a way, this verifying that the implementation of the system matches the requirements is the definition of testing. In like a niche way, it's one definition of the word testing. So that's one way you could have gotten to the answer. The other way is to do it deductively, right? So requirements analysis, while we're doing requirements analysis, we don't yet have an implementation. So, because we haven't gotten to the development phase yet, right? So it can't be in requirements analysis. The release phase, you wouldn't be verifying the implementation. Like once you're releasing the system, hopefully it's already verified, right? The design phase, again, we don't have a system yet. We're designing the system. We don't yet have it finished. And so deductively, you could have gotten to that it was testing. But I suppose the best way to approach like all 5 of these first questions, probably the best way would just be, through study, you would just be able to instantly know these, right? It's not really, it's a lot of theory knowledge. You are planning to develop a new software system for your organization. You need to review the plan for packaging, deployment, delivery, and support of the software. Which of the following should you contact? Which of the following should you contact? Interesting. So you're planning to develop a new software system for your organization. You need to review the plan for packaging, deployment, delivery, and support of the software. So a release manager would do this. You see, I'm even questioning myself here because quality assurance manager does sound like a person who would. No. Release is safely the correct answer here. But let's see. So what page would we read more about this on? So you would, if you want to read more about release manager, you could head over to page 68. Okay, 68. So deductively, we know it's not the architect, a technical architect. Have we even seen that term? I mean, technical architect is almost made up, right? Because you would just call them an architect or a software architect. Database administrator administrates the database, right? They don't handle packaging. Quality assurance manager, you see, so part of the reason why I would say you would never answer this one is because on page 68 of the book, they've given you a set things for release management, and the release manager is the person who handles those things, right? So you can see that a quality assurance manager isn't really something that's discussed. So that's one reason. Oh, sorry, was that a question or just background noise? I don't. You have completed. Okay. Someone, I can hear you. I don't know if you're trying to ask something there. Oh well. Okay, so you have completed developing a new software application. To ensure the quality of the software, you need to verify that each method or function has proper test cases available. Which testing approach should you use? Okay, so here, immediately you should eliminate alpha and beta testing because we're not talking about users, right? So we're firmly in white box or black box, and we had this discussion about some of the ways we could classify white box and black box testing. So we're ensuring the quality of the software. We need to verify that each method and function has proper test cases available. So remember, white box testing requires us to know things about the system, right? When we're using our knowledge of the system to ensure that our testing is appropriate. So when we see that we need a test case for each method and function, right? We know what a method is. Function, it's kind of a bit of a redundancy that they say both, but we know what a method is. In order to know all of the methods in the code, and in order to know that they're all tested, we need to know the code, right? We need to know how the system works. And so the answer there is white box testing. Hopefully that one didn't catch too many of you out. The next one, probably the first time, this one might have even caught me out. You have completed developing several major features of a new software application. You plan to provide an early look at the product to important customers to gather some early feedback. Your application still misses features and you haven't yet optimized the application for performance and security. Which kind of testing should you perform with a limited number of important customers? So the thing here, this is the definition of alpha testing, right? But black box testing is in a way correct, because the customers that are testing the application don't know its inner workings. Okay, so I would have forgiven you if you were thinking along the lines of black box testing. But yeah, the answer here is alpha testing. And this is partially why it's good for you to go over these mock tests, because you'll get used to the idea of like the more correct answer, right? Because this is the definition of alpha testing. The fact that alpha testing is sort of a subset of black box testing should maybe be considered in like a written test, but in a multiple choice test, the most correct answer is the correct one. Okay, this one a little tricky just by the options that they give you, but it's still okay, still okay. You are developing a new application that optimizes the processing of a manufacturing plant's operations. You need to implement a data structure that works as a buffer for overflow capacity. Okay, what is the difference between beta and black box testing? So beta would be, you see, this is the thing. So see alpha testing and beta testing as a subset of black box testing. Okay, if you want, and they have once asked that, where they said, is alpha testing an example of white box or black box testing? But the thing is, when they actually give you the definition of alpha testing or beta testing, so showing an initial version of your product, so alpha testing is like an earlier version without performance and security. Beta testing is just like a pre-release version. When they give you the exact definition of the type of testing you're doing, pick the exact definition rather than black box. Okay. But again, I do like if I made the test, black box would also be right here. Honestly, I would have given you a different option because I do think this is vague. Because technically it's not wrong to call this black box testing because the users don't know about the inner workings of the code. But hey, I suppose the other way you could look at it is that here the users are testing the application, whereas black box testing is kind of like you could be testing the application and just not using the fact that you have knowledge of it, if that makes sense. But yeah, Christian, it is you know, Microsoft makes the test. So we do have to, you know, work within their sort of scope. But does that sort of explain what you're asking? Are you okay with that? Cool. Okay. So you are developing a new application that optimizes the processing of a manufacturing plant's operations. You need to implement a data structure that works as a buffer for overflow capacity. When the manufacturing capacity is available, the items in the buffer need to be processed in the order in which they are added to the buffer. Which data structure should you use to implement such a buffer? Okay, I was focusing so much on my reading that I didn't actually comprehend what they were asking. So the items in the buffer need to be processed in the order in which they are added. Okay, we did bring this up because I asked you a similar thing in the quiz once before, because I also, the first time I saw this question, I was like, in the order in which they are added is not specific enough. They should say in the same order in which they are added or something like that. But you have seen this before, so that's no longer an excuse. So when they say in the order, they mean first in, first out, right? And so we say Q. I think maybe this is like an Americanism that there is only one like strict order, because you could see like a stack as in the order, but it's just, yeah. There's no end. Again, we have seen this before though, right? Multiple choice questions, there's only so many ways to make them difficult. You are developing a new application that optimizes the processing of a warehouse's operations. When the products arrive, they are stored on warehouse racks. To minimize the time it takes to retrieve an item, the item that arrives the items that arrive last are the first to go out. Okay, so I don't even have to read the rest of this. Last in, first out, it's a stack, right? It's a stack. I don't want to go over stacks and queues again because we did cover them very recently. I think most people got it in the lecture. So if you're worried about this, go back and watch that lecture recording for queues and stacks. But hopefully these two, right? Queues, first in, first out, the same as they are in the real world. Stacks, last in, first out, like a pancake stack, same as they are in the real world. Okay, so you can just picture it that way. If you're super worried about it, actually draw out what they're saying, and you should be able to get it. Okay, so this one was the new one. Hopefully you saw this one and you saw why we went over this topic just before. They went a little bit extra here, right? So there's 4 rows this time. But hopefully we did cover this just before, but we can, again, I'll be specific about it and go through. So they're asking us 2, 3, what number would we get out, right? So we start counting row 0, row 1, row 2. So this one that starts in 89 is the row we're looking for, right? And all we had to remember there is just that it's rows, columns, right? And then you can go through it, right? So 0, 1, 2, 3, we're going to get 34. Now, what's cool about this one is that they were quite nice on this question, because even if you forgot that it was rows, columns, you still couldn't have gotten it wrong, because if you went columns, rows instead, you would have gotten 79, which is not an option. Okay, so they were nice in that, like, if you started counting from 0, you would get this one. You would get this one. Okay. Cool. So in your application, you are using a queue data structure to manipulate information. You need to find out whether a data item exists in the queue, but you don't want to actually process the data item yet. Which of the following queue operations will you use? Okay. This one you had to be a little bit careful for, right? So they're not asking us to find the next item in the queue, right? What is the answer here, guys? Does anyone know? Okay, good. Yeah, so we did cover contains just before we started, and yeah, okay. So maybe Vesh, you might have been a little bit on these two. You might have been a bit worried if you didn't see the start of the lecture. But we basically go over these 2 topics. So go back and watch the lecture recording, and you should be good. Cool. So you are developing question 14. We've only got a few more to go. We're going to go a little bit over time, guys. Hope you don't mind. You are developing an application that uses the stack data structure. You write the code below. What are the contents of the stack from top to bottom after these statements are executed? So this one, I would have actually drawn it out. I do, there is a mouse right here. I guess I can actually do it. Or I'll just use my touchpad and you guys will just have to bear with me. Okay, so there's a stack, and yeah, if you guys are ever worried about this, if you don't want to do it in your head, you can just do it like with levels, with your hands or whatever, but try to visualize it because that's the easiest way to picture it, right? So we're actually going to make a stack. Okay, so we create a stack. So we've got some kind of line. We put 50 on the stack. So 50 goes on the stack. Drawing with the touchpad sucks. Okay, that's a 50. Take my word for it. So we push 50 to the stack. We push 45 to the stack. Honestly, that 50 is not so bad. Okay, this 45 is terrible. Okay, not a bad 4. Okay, yes, you saved me. Cool, nicely done. Cool, so we push 45 to the stack. We then pop. Okay, we pop, so this is removed from the stack. I guess the better way to do that is to use the eraser. So we pop that off the stack. Okay, we pop the top thing off the stack. We then run push again, push for 11. So, okay, 11s are, okay, I was gonna say how easy 11s would be to draw, but apparently not. Okay, cool, we got an 11. Great, so we push 11 to the stack, and then we immediately pop 11 from the stack, so 11's gone. And then lastly, we push 7 to the stack, so that's the last one. And we got a 7. Great. Okay, so when they ask the question at the end, what are the contents of the stack from top to bottom? From top to bottom, we start at the top, it's 7, and then 50. Okay, cool. So it's not too bad as long as you just go through it step by step, right? It's, yeah. If you know what, if you remember what push and pop do, and the same for a queue, right? If you just draw it out, you will manage to get it. But yeah, these kinds of questions, if you rush them, you can mess up. It is possible to mess up. So unless you're feeling super confident about stacks and queues, then maybe just take the time to actually draw it out like we just did, okay? So 15. In your application, you are using a stack data structure to manipulate information. You need to find which data item will be processed next, but you don't want to actually process the data item yet. Which of the following queue operations will you use? So now we're just looking for the next one. We're not asking if it exists in the structure entirely. We're just asking for the next one, but we don't want to process it yet. And so we use peak. In a way, this one was also a little bit weird because they tell you you're using a stack data structure, and then they ask you which queue operation you would use. But they're forgiven because peak is technically a queue operation as well. But obviously that should say stack operations, but whatever. Okay, this one, we would have to explain, in order to explain this one in more detail, I'm gonna have to explain the quicksort algorithm to you entirely, rather than just telling you that it's quicker than bubble sort. And so what I'll do, I'm gonna post the Hungarian traditional dancing video on the YouTube, on the WhatsApp group as well. And I'm going to make an animation so that we can quickly discuss how quicksort works. And we'll go through that at the start of next week's lecture, rather than boring you now with learning another algorithm. The answer here was A though, and how you could have gotten that was partially just looking in your book at the bottom of page 80. But obviously we want to understand in a more fundamental way than that. I gave Christian that brief, not super satisfactory answer, but we'll learn more about quicksort next week. We do sort of have some time to work with now, so we'll discuss it in more detail. You are studying various sorting algorithms to understand, analyze, and compare the various sorting techniques. Which of the following techniques should you utilize when using the bubble sort algorithm? Okay, this one you should have been able to get based on our discussion of the bubble sort algorithm. Anyone have a suggestion? You can just say A, B, C, or D rather than writing out the whole thing. But this one I would have wanted you to get. Okay, B. Yeah, that's good. And so the reason we know, oh, someone marked it as well. Cool. Yeah, so the reason we know it's B is because it's what we said, right? Bubble sort works on comparisons and swaps. Okay. Maybe I'll go over just quickly because these are maybe difficult questions, probably the most difficult from section 3. So we will maybe discuss it one more time when I show you that quicksort animation. We are not going to go through the entire quicksort algorithm because it will just take too long for these singular weird questions, and they would I don't even think they ask this anymore. Currently, they would ask you how quicksort works, which would be on partition and swap operations. But yeah, we'll discuss it a little bit more next week. Okay, so question 18. This one you've almost seen before, but the words have been switched around a little bit. Okay, so you're developing a C# program that makes use of a singly linked list. You need to, so there's only links in one direction. There's no pointer to the previous thing. So you can't start at the tail node and move backwards. You're developing you need to traverse all the nodes of the lists. Which of the following items will you need to accomplish this requirement? Okay. So this just has to do with how we traverse a singly linked list. Did someone say something? It was just me echoing back to myself. So data in the head node and data in the tail node, you should immediately exclude. Okay, I've told you before that data they are using as a synonym for in a way, data could also encapsulate the pointer, But no, just think of it as value. Okay, so they're just saying, they're being too vague. They're saying like, oh, you could take the number in the head node or the number in the tail node, the value, or maybe the head node as a whole, like some arbitrary thing like that. But that's not what you start with, right? And that's not the most important thing that we need. The thing that we need is the link to the head node. So that pointer, that first arrow that points to the head node, that will allow us to point to the next node, that's what we need. Okay. So because we need that original link so that we can get to the next thing. So you have been asked a very similar question. They switch around the wording a little bit each time. So link, pointer, data, value. So just be sensitive to that, to the fact that they can move around the words. Okay. Last two questions. Which of the following is not true about linked lists? These questions always confuse me because thinking about not trueness is just, but anyway, it's not too bad. So a linked list does not allow random access to its items. So that's true, right? Because on a linked list, if you want to get to a specific item at a specific place, you have to traverse the entire list up to that place, right? You have to go next, 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 or previous, 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 previous. If you're working with a doubly linked list, you could have started at the tail node and gone previous, whatever. So yeah, you have to traverse. You can't just, like with an array, randomly decide to access this point, right? You have to be specific, okay? A link to the head node can help you locate all the nodes in a linked list. So yeah, that's true. In fact, we saw this in the previous question, right? A link to the head node helps us locate all the nodes in the list. The items in a linked list must be stored in contiguous memory locations. Ooh, that is false, right? The whole point of linked lists, and yeah, we explained it when we introduced linked lists, right? Arrays are in contiguous memory, which means that we can't just insert more data, right? Because we would have to move the array to a point where it has enough space in memory. Linked lists solve that problem by just allowing us to put nodes wherever in memory we want, and we just point them to each other. So it solves the problem of arrays being in contiguous memory. So yeah, this is false. The items in a linked list don't have to be stored in contiguous memory locations. In fact, the whole point of a linked list is that they don't have to be. Okay. Linked lists are extremely fast in performing insert and delete operations. So we already know that this is true, but I just want to emphasize it. This is true, guys, and they could have asked you about this specifically. Okay. The main reason linked lists are great is because it's very easy to insert and delete nodes from the list, because all you have to do is change where pointers are pointing, which is very quick. Cool. You are developing a program that performs frequent insert and delete operations on the data. Your requirement also dictates the capability to access previous and next records. Big hint there. When the user clicks the previous or next button. Which of the following data structures will best suit your requirements? And someone just conveniently added the D in front of doubly. So yeah, they gave us array, circular linked list or circularly linked list, linked list or doubly linked list. Now, technically, let me think about this. So hypothetically, I would forgive you for thinking circularly linked list is a valid answer, although they don't tell you that the last thing should be able to access the first thing, right? Like they don't tell you about that. And so yeah, oobly linked list or doubly linked list is correct. And the fact that they so specifically reference previous and next, the fact that they're so specific about it, really, it's quite a big hint that they told you that specifically, okay? But yeah, hypothetically, circularly linked list wouldn't be bad here, to be honest. You're developing a program. Yeah, it would work too. But yeah, again, Microsoft makes the tests. And so that is it, guys. I'm glad most of you seem to think that it went quite well. In fact, basically everyone asked, so that's good. And yeah. That's basically it for chapter 4. We will discuss quicksort more next week. If you haven't done the kata on Code Wars called Sort Numbers, please do. Okay, please do it. And yeah, so please do that kata. I'll give you guys an extra week. Maybe I'll also post a template on the group of how you must do it, just in case anyone was still having difficulties. Okay, and yeah, I think that's it for today. Enjoy your weekends, enjoy your afternoons. I'll also post the Hungarian traditional dancing explaining sorting algorithms. It's great. I do recommend it. Clearly put a lot of effort into it. Also a very strange idea of them to have. But yeah, that's the end of chapter 3, guys. So next week we can finally start chapter 4, which will actually be fun. Oh, and do remember, if you haven't done it yet, set up that file that we were talking about, right? With like the HTML, CSS, and JS, because we will actually use it next week. Cool. Thank you, guys. Cheers, everyone. See you.
So you must enjoy the weekend. Thank you.
Yeah, you too. Yeah, cheers, everyone. Glad the test went well. And yeah, I'll post the recording as well. Cheers.